Hello everyone, in grade 6 math, section 9.3, we are multiplying tenths by whole numbers. Of course we can do this with a calculator, and that would give us the right answer. And I'm going to show you today a little bit about why those right answers work. If we were to take a look at this model right now, that I have in front of us here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 different sections to this one rectangle. If I call this entire rectangle 1, then we know from fractions that each one of these smaller rectangles would be 1/10, because my 1 is broken up into 10 equal pieces. So one of these 10 equal pieces would be 1/10. These two of the 10 equal pieces would be a total of 2/10. And similarly, 7 of these pieces would be 7/10. And that's what we're going to be going by for this section. So now that we know what a tenth is and what 1 is, we can start to manipulate these various ones. Similarly, if I have 4 ones, which you see here, this is 1, 2, 3, 4, these would contain 10 tenths in the ones, in this one, 10 tenths in this one, 10 tenths in this one, and 10 tenths in this one. Thus, I would have altogether 40 tenths. And of course, we know that this equals 4, and that's the equivalent fraction. That's how we're going to be adding these up and multiplying these today. Our first question we'll complete is from the homework, section 9.3, number 4. The question asks, calculate using base 10 blocks as a model. Sketch your model. And the question is 5 times 26. 5 times 26.7. We have multiple ways of being able to show this. However, one way that we can show this is by starting off with the 5 times 26 and using this any which way we want to complete gives us the 130. That leaves us now with 5 times 0.7. And that's what we're searching for. To get this answer, we can use our base 10 blocks. So from up here, we can take as many as we require to get as many tenths as we can. To show this 0.7, as we talked about earlier, that's 1.7, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. That's how I can show 0.7 using our tenths model. However, I would need 5 of these. Right here, you see I have 5 different models, and for each one, I'm going to show a 0.7. These dots would represent, each one dot represents 1/10. So all the dots together would represent 0.7 in one frame, as well as how we're going to do it right now by adding up all of these dots. We can count all the dots one by one. That would work. However, we can see that there are 5 different groups of 0.7. So if we did 5 times 7, this would give us 35 tenths. And that's our 35 tenths, coming from our 7 here, and 7 here, and 7 here, 7 here, and 7 here. So if we multiply those 7 by 5, we get 35 tenths. Thus, 5 times 0.7 is 35 tenths. And from this, we are able to say 130 plus 35 tenths equals our 133 and 5 tenths. One other way we can show this would be by recognizing that every single one, like we have here, like we talked about already, that is a 1. Well, here we have 26 ones. So the value of 26 ones would be 260 tenths. And 260 tenths is 26, because each one has 10 tenths in it. So here we have 260 tenths plus 7 tenths gives us 267 tenths. Every one, 26.7, has 267 tenths. However, we don't want just one group of 267 tenths. We want 5 groups of 267 tenths. And from here, we would be able to get our same answer as we had at the top, 133 and a half. If we use the calculator, for example, for this, we would get 133.5. And that would be number 4. To move on to number 5 now, the question asks, Jane walks 2.6 kilometers each day. How far does she walk in 1 week? In this question, we may rewrite that as 2.6 times 7 days. And similarly, we can make groups of 2.6 in terms of our tenths, but we know that 2.6 is like saying 26 tenths. So if we have 26 tenths, we say 26 times 7, like that. Using any method that we might find applicable, 26 times 7 is 182. So we have a total of 182 tenths. And if we were to lay all these out using our ones models from before, we would have 18 full ones and 2 tenths. In other words, 18.2. And that's number 5, 18.2 kilometers.